Feels like a traveling circus. Arnaud and I were just in Fukuoka, Japan at the W3C meeting, and now we're here, and next we're going to be at IAW next week. So I'm going to, as Arnaud said, go the next deeper level, not really technologically, but with explaining what we're doing to establish the standards and the interoperability that will be necessary for self-sovereign identity. And this, I love this term, saying goodbye to Mr. Login. I want to credit John Jordan at the province, British Columbia. His cohort, Stephen Kern, will be here on the panel with us. But John is the one who came up not only with the idea of Mr. Login, but the idea of the icon and the idea we need to retire him. So we're going to talk about what it takes to actually do that. This set of slides, I love it. You know, everyone gets out their phones and takes pictures. But if you want actual the slides on your phone, just scan that QR code, and you'll have the presentation. And you can. The one thing I ask is, don't tweet a slide before we actually present it. Not that there's anything particularly controversial in here. All right. Hopefully, if you capture that guy. All these things I think are all the MyData presentations are being, yeah, they're all going to be shared anyway. Okay, so I'm going to sort of, again, take over where Arnaud explained it, the big picture of SSI. I'm going to talk about, again, how we're going to standardize it, but I always like to reinforce to make sure it's clear what is new about this new model of digital identity. And the old model, the model we started with, is account-based, right? You exist because of the set of accounts you have out there on the internet. And that's why you're a dotted circle here, because you take away all those accounts, you're gone. You don't have any real existence on the internet. Now, we had to improve on that because it was so painful as the internet came out there. By the way, that's where this guy got introduced. That's where he got born, when we moved out there on the internet and said, okay, that's why every single thing, you know, site or app you interact with, you've got to encounter Mr. Login. And John's point is, that's not the way it actually works in the real world, right? When I go up and meet Katrina for the first time, I don't turn around and say, Katrina, talk to my login agent, right? And vice versa. So that's where it started. Now, we then said, okay, it's so painful, let's solve this problem, and we'll put an identity provider in the middle, and that's where Mr. Login will live, okay? How many folks out here have used Google or Twitter or Facebook or a social login button on some website to log in? And yes, we do it because it's more convenient, and yet we know we are you know, there's a privacy issue there, there's intermediation issues, all of those things. These have been the predominant models for digital identity because they were the only ways we had to solve the problem. Now, what we did when we are moving to SSI is we really are substantially changing the underlying model. We're getting away from account-based model, and we're moving to peer-to-peer, just the way the internet works today. Every time your device connects to some other device, your browser talks to a web server, it's a peer-to-peer connection between two IP addresses, internet protocol addresses. Well, what we're doing here is we're saying we should be doing the same thing for identity. And I'm going to explain what makes this peer-to-peer connection possible. Now, the first thing is you look at that and you go, oh, we're going to have Mr. Login all over again. And the answer is, no, we're not. The way we're going to get rid of that guy, we're going to retire him once and for all, is we're going to implement this by saying, okay, each of you is going to have what we call an agent, okay? It's going to be on every device you have, just the way every device you use today has an operating system. That's how it talks to the rest of the internet, right? It's going to have an agent, and that agent is going to have a wallet. You've seen presentations already here, an excellent one yesterday on digital wallets, and there's some being demonstrated out there. That wallet's going to hold those private keys you need to have secure communications, to prove your control of that information. And it's going to store credentials. And this is the point at which I get out my wallet. Yeah, people are laughing because I do this every presentation, and I'm trying to carefully cover the credentials there. But this is self-sovereign identity, okay? It works in the offline world. It's worked pretty well. It's not perfect, but pretty well. We simply need to get this online. And everything we're doing here that we're going to go over here is the cryptographic infrastructure we need to do this on a decentralized basis, on a secure and private basis worldwide. I'm going to leave that there because I know we're going to come back to it. So the key, literally, to making that work in a decentralized manner is how are those two parties going to know when they exchange credentials that they're valid? And that's where, as Arnaud explained, the blockchain piece comes in. What we've established there is a standard address for a public key on a blockchain. Now, if you understand blockchain technology, or at least the basic that it's an immutable ledger with a very strong guarantee that that data is the data that was written there, right? There are hundreds or thousands of computers that are collaborating to ensure that cryptographically that data is exactly what's there. So if you write a public key at a DID address out there on a public blockchain, anyone else in the world is going to be able to verify that really is the public key for that DID address. And that gives us what we call decentralized public key infrastructure. It takes the current roughly 200 certificate authorities in the world that are built into your browsers so that you can trust the little lock on your browser, and says any company, any group, even an individual can have that same authority of what we call root of trust for a public key, and therefore sign credentials, transactions, messages, all that, okay? So this basic model is, again, as we, I want to get now into what makes this work and how do we scale it. So the reason those credentials can be trusted is this core trust triangle. And again, every credential in this wallet corresponds to exactly that trust triangle, right? When this is a passport card from the United States government, they are the issuer right here, beep, okay? They issued that credential. I'm the holder in my wallet, and when I need to go get on a plane, I have to give that credential to an agent, and they verify it. They literally are going to look at the biometric, they're going to look at and say, yeah, this is a verifiable credential, I can get on the plane. So what we're talking about with verifiable credentials is that issuer gets a DID on the ledger that it wants to, on the DID network that it decides it trusts to do that. And they issue a digital version of that credential, and they sign it with the private key for that DID. And that's what goes into my digital wallet, for instance, on my phone. Now I go to for instance, the TSA to get on a plane, and instead of showing them that credential, I take my phone, and just like I would have a mobile boarding pass, which is how I got here, I click a button, and I produce a QR code, and they scan that. And that version of this credential is much stronger, both cryptographically verifiable and verifiable that it really belongs to me than just that picture in there, okay? This whole thing we're talking about here, this trust triangle, the TSA only trusts that because they trust the issuer of that credential. This trust triangle is how trust works in the real world and how we're doing it digitally. And it doesn't have to be centralized at all. Anyone can issue credentials. Anyone can hold them. Anyone can verify them. They can all do that according to their own policies. So that's the essence of what we're doing. Now, how do you scale a system like that so that we can get interoperable trust on a very wide basis? That's this next step of starting to nest these trust triangles. This one we call the governance triangle. There isn't a credential. There's several, in fact, but I'll illustrate just one. This credit card here uses this second trust triangle. In this case, this happens to be a Visa card. The governance authority is Visa. Visa today authorizes banks to be issuers of credit cards. They give me the credit card as the holder. I go to any merchant out there that uses the Visa network to verify, yeah, it's a real card, and they can charge me. They trust that card because they trust it came from an issuer on that network, and those issuers were all subject to governance authority. The rules, the policies that governance authority follows is called a governance framework. Again, some of the largest networks, trusted networks in the world, the credit card networks, the passport network that we all use for travel and governments, those are examples of governance frameworks already working global scale. What we're doing now, and the last things I'm going to be showing you, is how do we take that and say it can work for any trust community of any size anywhere. Yes, governments, but corporations, consortia, universities, churches, schools, your neighborhood, your family. Okay? Shouldn't matter what size a trust community is. All of them should be able to establish trust the same way. So what I'm going to do now, again, having stressed that, is explain how we're standardizing this. And this is my third MyData, and each time we're sort of explaining the progress, and I'm always excited about it, but I have to say where we're getting to now is really exciting. So anyway, I'll go through this. So we're calling this is the SSI stack, and it's 4 layers. The bottom layer is exactly what Arnaud and I were explaining, DID networks with DID methods, public networks. Now, I'm showing 5 here, but every one of those represents some DID method that has been developed such that there's a network it runs against, and everyone higher in the stack can say, I want to use that DID method, I want to use that network to issue my credentials, okay? There are, yes, sovereign's been mentioned, but you can use public networks like Bitcoin or Ethereum. You can use other SSI specialized networks like VerisOne. You can use specialized networks, whatever. That's the whole idea of DIDs, is we're actually going to get a Darwinian selection, a competition for the best DID methods, the most trusted DID methods. Fantastic. The point of the DID, of what we're now standardizing at W3C is rock-solid, interoperable specification for DIDs to work everywhere. This is the cryptographic equivalent of DNS. What makes all of our browsers and web pages interoperable today is they can all use URIs to link across anywhere in the entire web. With DIDs, we are creating a cryptographic web. Those DIDs are the addresses. That's what your wallets are going to resolve, literally, to form a connection with another wallet, another agent, anywhere on the internet, and then have this secure connection over which it can exchange verifiable credentials to prove trust, but do anything else. Like I said, it's an entire cryptographically verifiable web. So this working group just launched last week, as we were talking about. I actually, as of this morning, 54 members of that working group, 18 companies. It's off to a very, very fast start. I just did, actually, between Marcus and I, we've done, and Brent Zundell, I've done 2 webinars on that, both of which, one is this SSI meetup, and the other one, Evernym just did yesterday. So if you really want to know more about DIDs and the working group, please look up either one of those webinars. So that's layer 1. Let's jump up a layer to the second layer. And here is the really important point that Arnaud was trying to make. There's this common perception that somehow your wallet and your credentials are tied to a specific layer 1 DID method. The whole point, if this wallet was somehow tied to some of the credentials in here, and I couldn't go put in any credential or take out any credential I wanted, I wouldn't use it, right? Similarly, if somehow my bank account, by putting money in it, it was tied to that bank and I couldn't move it someplace else, I wouldn't use that bank. You should not ever even contemplate using a wallet that is tied to a specific operating system. Now, I'm guessing the majority, I'm not even going to ask for hands, but iOS and Android phones have a built-in wallet. You're probably using that every day, like for those mobile credentials. Those are proprietary wallets. You cannot interchange credentials in there. You can't interchange value or tokens. That is what we just can't stand for that, right? There would be no MyData if we actually locked things in that way. So the purpose of this stack is to ensure that this second layer, the agents and wallets, are interoperable across all these methods, and they do not lock you in. That's the whole point of these open standards. Now, at the second layer, the standardization is, there's a long political story, but it's not at standards bodies yet. The work that, as Arnaud explained, is going on in the open source community. The project he was talking about, Hyperledger Aries, was, again, spun off from the original SSI work there, specifically to say, we need this layer to be interoperable. We need it to work independent of just indie-based networks or networks like Sovereign. We need it to work with any ledger, Ethereum, Bitcoin, whatever. And also, notice this. The default that's been adopted there is that when you form connections, direct peer-to-peer, you're actually using what's called a peer did, which is not on any ledger. It's exchanged directly wallet to wallet. It lives in your wallet. It lives in the other party's wallet, be it another person, organization, or thing, your car. And those wallets, in turn, their owners, the holders of those identities, have a backup for those wallets. It might be in the cloud. It might be on a hard drive. It's whatever. Everyone does it their own way. That's what self-sovereign identity really means. You have your keys, you have your wallets, you have your credentials, and you control them, and you control where they live. So this is not the only place. In addition, we have the Decentralized Identity Foundation is working on their approach to interoperability, and Digital Bazaar is another company that's working on it. The whole point is these things need to converge in the stack, and we need for that to be interoperable. Now, together, these first two layers only establish cryptographic trust. I want to make it clear that that's all we've accomplished at that level. But the whole point is to separate that cryptographic layer of trust from the human trust that we need as individuals, as organizations in the world. That's where verifiable credentials, the trust triangle, comes in. And that's what Arnaud was explaining when we were going over earlier. And the nice thing about that is the most advanced standard we have out there. This working group just completed its work at W3C. That's the URL for the specification. It's called Verifiable Credentials 1.0. And that specification has 3 formats of credentials. I mean, it'd be great if they could all converge on one, but there's enough variance and the different advantages of the formats in cryptography. One is linked data signatures, one's called JSON Web Tokens, and the third one is zero-knowledge proofs, specifically Kamenisch-Lisenskaya zero-knowledge proofs. And you can dive into the spec, as I put up there earlier. I want to say one thing, which is from the standpoint of MyData and what we care about here and what we're trying to build, there is a special point about zero-knowledge proofs. And I want to be very clear. We are at a key juncture in the evolution of privacy infrastructure for the web as a whole. And I believe one of the reasons I'm here at MyData each year, this is one of the places where we're going to send a beacon to the world. We're going to set the direction. Are we, as individuals, going to say, yeah, it's totally fine to have correlatable credentials, and I start sharing those all around the web, and forget about your government ID or your cell phone number. You're going to be the most correlatable in the world. That's what happens if we as individuals, they're fine for businesses that have to be correlated out there, but the other path says, no, we're actually going to adopt, and we're going to have the businesses and the governments we interact with support the adoption of zero-knowledge credentials, which let you selectively disclose information. When you go to a bar, you can only prove you're over a certain age, right? When you go to qualify for a loan, you can prove you have a certain level of income without giving up all the other data that will be used to track or market to you. So I think this is a really critical point, and this is a choice we are going to make as individuals, as companies, communities, and governments. So please think about that. All right, so there is still one more layer to the stack, and some would argue it's the most important layer of all. It's governance. I talked about it earlier, the credit cards in this wallet would not do a single thing with the entire technical network in the world unless there were a set of rules that the banks and merchants had all agreed to abide by. And as a matter of fact, every one of us that has a credit card has also agreed to the rules as a cardholder. It's those rules that establish the trust in the system everyone's going to follow that make those things work. With verifiable credentials, every credential that I have in this digital wallet is going to have a governance framework behind it. Some will be very large and be like the credit card networks. The credit unions have formed a consortium called CU Ledger of the credit unions. It's actually now a global consortium to standardize on a single digital credential of credit union membership. They want to establish that as something you can use, whether at a credit union or any place else in the world, to prove you have a KYC, know your customer, verified account at a credit union. That's a really powerful credential, and they're going to be the first ones in the world to do it with a governance framework designed to work anywhere in the world. I think there are going to be many more examples. Again, the power is we can now do that for first tens, then hundreds, then thousands, then millions of different credentials that will work for every community that needs them. Okay, so last thing I want to show you is governance turns out to be such a critical element that it actually applies at every layer. So I'm going to introduce one last term, and again, I'm going to credit John Jordan at the government of BC. He's very good at saying, hey, we need to talk about this as more than just self-sovereign identity. This is actually how we're going to build the trust layer of the internet. So he suggested, let's adopt a term, trust over IP, sort of based on the idea of voice over IP. How do we talk over the internet? Well, this is how we do trusted interactions over the internet. Now, this side of the stack is what I just showed you. But his point is, that's all basically technology all the way up to the top layer. We actually need governance at every layer. So the next step in developing this is to say, with the trust over IP stack, there's going to be network governance frameworks at the bottom layer for every network. It doesn't matter what it is. If you're going to trust it, even if it's permissionless, like Bitcoin or Ethereum, how is it governed? Who governs that code? If it's completely out to the, up to the wild, you got to ask some questions. So regardless how it's governed, you can have a network governance framework. These, by the way, are different standardized roles at each level. Same thing for agents, wallets, agencies. There need to be standards. How does a verifier know you're using a wallet that's safe? Okay. The next level up is where we're already seeing so much development, and there are the governance frameworks behind credentials, like the Visa or MasterCard or CU Ledger credentials or everything else. That's where I think we're going to see thousands of different governance frameworks. At the very top level, we have what we call meta-system governance frameworks, and this is where organizations like the Sovereign Foundation are now moving and saying, we need to actually create a meta-system for as many networks, as many providers, as many credential issuers as want to do that. So this is the complete picture of the trust over IP stack. This is now being turned into a Hyperledger Aries RFC so that we can just talk uniformly about it and talk about the standards that are needed at every level. And I'll wrap up just by explaining, so what is going on at the Sovereign Foundation? I'm one of the trustees there, and I chair the governance framework working group. So Sovereign is evolving, and it is evolving in the direction of saying, we're known as one network right now. We need to become a network of networks. We need to embrace all of the networks that want to come together under a governance framework under the principles that are already there. And some of those networks, some of the most interesting ones, are right here, in Europe, in Finland. So it's a very, very exciting dialogue. If you're not familiar with it, Sovereign Governance Framework, it's the one and only URL. It's a homepage for it. The first generation we did 2 years ago, finished the second generation in March, pre-GDPR. I mean, GDPR was out there, but we said, let's finish everything except for the very difficult question of how does self-sovereign identity actually going to work with laws like GDPR. We spent 9 months working on that, and we have a set of documents in public review at that URL up there. So if you are actively interested in that question, we'd love to have your feedback. There's a whole diagram and an explanation of the answers that we've come up with. And the next step is to develop a third generation for that whole stack that I just discussed. And we also now have 5 task forces that are building on top of this stuff. Guardianship. What do you do for someone Extend self-sovereign identity to someone that doesn't have a device, that isn't in a position to do something like that, like a dementia patient, refugees. All of these are very active topics. This task force is started in January. It's going to be putting out a white paper, the first draft next week at IW, and it's probably going to turn into a working group because there's so much interest in it. Another one on what we call domain-specific, those credential governance frameworks. SSI and IoT is a super hot topic now. Business models, business of SSI, and then the latest one is compliance and payments. So anyone can join these. You don't have to be a member of the Sovereign Foundation. There is no membership in the Sovereign Foundation. It's a volunteer. You can find them, just search Sovereign Task Forces. And last thing I want to say here is, I am no longer the chair of the Sovereign Governance Framework Working Group. I'm the co-chair. We just had Emily Fry from Matter in New Zealand, one of the companies that Arno mentioned, has joined as a second co-chair. We're actually open now to having a third, so we have representation all the way around the world. We're starting a new set of calls that will be optimized. If you're a global network, you have to have calls and connection, exposure for everyone in the world. So right now, US and Europe are well represented in Sovereign, but APAC, companies like Matter in New Zealand, we need more exposure there. Everyone, again, can participate. There's instructions up there. So as we prepare to go into the panel, I want to suggest, even though we're getting a good, robust technology stack and we're tackling governance, there's still some really big questions out there, and a handful. One's already been asked here today. How will it work with governments? How will it work for those on the other side of the digital divide? Things like guardianship. It's a huge issue. If we don't solve it, it could really stop SSI in its tracks. What will happen with privacy and the global privacy debate, surveillance economy? And then lastly, business models that really work. I've got good news for you there. We are not finding, my day job is with Evernym. We are seeing tons of customer interest. Those customers are companies, governments, alliances, associations that are seeing major either cost savings or user experience improvements. With SSI, one of the fascinating things is typically higher security means more friction for customers, and lowering that, and with SSI, you don't have to make that trade-off. You can get higher security, and you can get tremendous user experience. And that is really exciting to us as individuals, and it's really exciting to the companies that are trying to sell us products and services. So I'm going to stop there, because that's just to sort of seed the crowd. Hopefully, you're all on Screen.io, and we're going to move into presentations, right? Roundtable.
Yeah, the panel time. There's lots of good stuff coming into the Screen.io. Maybe we don't take them. We have 18 minutes for the panel, so we will take some of those questions hopefully during the panel if we don't have anything else. So let me welcome also Stephen Curran and Kalia Young to the panel with the microphones also equipped. Right. Okay. Stuff coming about the EU and government level SSI stuff I see as well. Interesting. So let me get started sort of with hopefully a good starting question for the panel. Stephen here has been already presenting a couple of times during the MyData conference today, this week, and it's apparent that British Columbia and Canada are moving quite fast forward with SSI. So, what are you really doing there?
We started with about 2 years ago. John Jordan, that we've mentioned a couple of times, he is with the government of British Columbia. I'm on the team he's got, the Verifiable Organizations Network team is what we call, VON team. We started with public data and sort of using that as an example that we could move with safely so that we could, screw it up and not get yelled at. And taking it and providing open data, but wrapping it in that cryptographic wrapper that makes it authentic data, so we can experience what it's like to communicate data that is trusted across the internet and see what the experience was. We built a couple of tools. We built a production website that is still working well, and we continue to expand. The next thing we're transitioning into is how to really retire Mr. Login. So that's what we're working on now. We worked with MyData Global, who was just mentioned, to have them, we put out a bounty that they won, and they've built for us a OpenID Connect mechanism that uses verifiable credentials. So basically what it allows is you can still have a federated login, but users can choose to log in via a verifiable credential. And so that will allow us to transition. So we've got a really cool use case we've got coming where we've got a government system that is for lawyers, and we want to allow lawyers in and nobody else. And the only entity in British Columbia that knows who a lawyer is at this moment is the Law Society of British Columbia. So they are the issuer of a credential. They issue it to a mobile agent held by the lawyer, and the lawyer goes to the website, and they can log in to the government website. And so that's our next experiment with it, and we're moving forward with that. The goal is really to allow citizens to have their data wrapped up and used with confidence. An analogy John uses is we make it safe for citizens to walk down the street in the province, but the internet is not quite so safe, and the use of their data is not quite so safe on the internet. When they type something in, when they type in their ID, they don't really know where it's going. By putting it into these cryptographic wrappers, by presenting their data as verifiable credentials, it gives them a safe way to transact on the internet, and that's really what we're after. That'll be enough for now.
That's enough, maybe. Maybe there's something else coming up. That's a later question. There was somebody asking earlier on the list that is there interoperability between OAuth and SSI? So Stephen was actually partially answering that question. It's OpenID Connect, which is more precise profile of OAuth actually for the identity management. So yes, there is legacy bridging happening.
I said there can be
if
you work really hard at it, which is what they're doing. I think actually that technically OAuth means open authorization, which is really about connecting two things, and then they put OpenID on top of it.
Yes.
But that thread is a very interesting one that's emerging in the community right now, which is, should we leverage the widespread adoption of OpenID Connect as a vehicle to spread SSI? And this may take a few adaptations to OpenID Connect, but I think it's a promising strategy. I was very skeptical at first. I was like, oh, we're doing the new thing, we should just do that. But one of the challenges with identity protocols and their adoption is relying party adoption. That is, all of the websites that are accepting these credentials, and that happens to be a widespread relying party sort of doorway, and we should really think about how we leverage it to allow them to just accept these types of credentials through those doorways they've already built.
Yeah, that's a very good point. Talking about European identity management, especially on the government level, so actually in not so many places we have even done the adoption to the OpenID Connect yet. So there are many SAML-based systems. Maybe one question to the panelists would be that if you are still running a SAML-based eID system, so should you even jump to the OpenID Connect or directly to the SSI?
We'll see.
Okay. So my question for Kali actually would be that so if that's happening in Canada, what's your view on what's happening globally on all the different SSI networks and projects?
Yeah, I think we're seeing a lot of different folks in Europe get very interested in the protocols and the technologies. There's a bunch of white papers by various entities in Europe of late. I think there's a lot of promise in developing developing markets around the world. I was speaking with someone in Africa and explaining because there's a big push by the World Bank and others to build centralized identity systems at a national level. And it's a bit concerning because there is a role, clearly, for governments to be authoritative sources of information about their citizens. The challenge is if you build systems where every time you use that identity that's digital, does it phone home to the government and tell you where you used it? And I think that is probably not a good thing to build in, especially in emerging markets with maybe questionable government accountability and other issues. Like even Western liberal governments, we don't want to know where you used your ID. So, and one of the folks I was speaking to was like, oh, this technology makes sense because Africa's already decentralized. Everybody actually has an identity, so it's wrong to say they don't. They may not have an identity issued by a formal institution, but there's certainly people who know where they are, and informal institutions that do. So how do you just start turning on the ability for existing networks that already know people to issue credentials to them that can work in a distributed way? So I'm excited about the potential to do this. And there's also a large network, proof of concept network, that's actually running between the US and Canada with customs clearance for packages. So there's a bunch of large-scale things happening that have almost zero press about them because they're trying to get them to significant scale before they talk about them. So I think in this year you'll see many more of the experiments and the early stage deployments that people have been working on be released into public view.
Right, and maybe not so much emphasized on the presentation is that these DIDs and credentials can really be as effectively with companies and things like parcels going out there in logistics as with person IDs or identities. I highlighted one question there because this is of very big interest for all the SSI deployers in Europe. So we
Who gets to be the lawyer?
Yeah.
Well, I'm working with them day in and day out, so I'm happy to answer that or provide at least a high-level answer. The short answer is yes, definitely. If a DID is registered by an individual or for an individual to identify them, it is absolutely a pseudonymous identifier under GDPR. So is the public key or the other information that would be in the DID document that's discoverable on that public ledger, which immediately introduces the issue of it's an immutable ledger, and therefore you have personal data on it. What do you do about the right of erasure?
Now, do you have precedence on that shows that to be true?
When you say...
That was rhetorical.
I know. This is a widely recognized issue. It has been for a while, which is why at the Sovereign Foundation, with the Governance Framework Working Group and the Global Policy Working Group and the Technical Governance Board, everyone has come together with the stewards and their legal teams to hash through what are we going to do with this. And I'm just going to summarize the answer. The answer is, yes, it's personal data. The only thing we can do, because it's an immutable ledger, is actually have a legal infrastructure where every entity, person, or organization that writes to that ledger is going to do so under a transaction author agreement. It's a global document, one of the ones in public review right now at that URL I shared before. And it says, if you're an individual and you're writing a DID for yourself, you acknowledge you're writing it to an immutable public ledger. And that we can't do anything about erasing it. You can throw away the private keys because you're the actual data controller. And for legal reasons only, the Sovereign Foundation acts as what we call the designated data controller in order to have all of the stewards of the network serve as data processors. And that's the legal architecture. The agreements are all there. The architecture is all there for everyone to review. Please provide your feedback on it.
But isn't the norm that people aren't really writing their DIDs to ledgers anyways? Like mostly the ledgers in this technology are used to store the keys of businesses and other institutions issuing verifiable credentials. As you saw in what Drummond outlined, peer DIDs are between people and institutions. And there's no reason a person should ever have a DID for themselves on a ledger unless there's someone like me who might be like, my small business puts a ledger and I happen to be very close to my business, but that's different than Joe Public.
Right. Kalia's right. The vast majority of cases, individuals should not need DIDs on public ledgers. But those edge cases, some folks care quite a bit about. One of the common examples is you're a blogger or you're a celebrity. You want to issue credentials or statements that anyone can verify your signature. Well, for that, you need a public key that's widely known. So the position that we've taken at the Sovereign Foundation is SSI should be for everyone. The ability to use a public ledger should be available to individuals. They just need to know that there is, it's going to be immutable what's there. So.
But I think it's important to highlight. I agree. I'm glad you clarified this because your answer kind of surprised me in the sense that in the scenario I described earlier, for instance, where you have a university issuing a diploma, a credential for the diploma, the keys that are stored there, the DID, is not the user's DID, right? It's the university. So GDPR does not even apply in this case. And so it's very important to realize that in many scenarios we're talking about covering with SSI, GDPR does not come into play because we don't store personal data on the ledger. However, I just want to also point out, as I mentioned earlier, I was part of the EU Blockchain Observatory where we had extensive discussion on GDPR. And in general, there's a lot of lawyers that were part of this. And what was interesting is, there's still a lot of debate as to what qualifies as personal data and what doesn't when it comes to keys, for instance. Some people say, well, a public key is already personal data. A hash of personal data is personal data. And, I'll share this because it's kind of funny, is at the end of the whole workshop we had on this, they basically said, okay, the jury will decide in the end what, is personal data or not, and how far you can go with regard to all these things. And so basically the conclusion was, okay, the first one who gets sued, please let us know, because we're all interested to see what the courts will decide.
Okay, maybe a bit related. So because so many organizations and people are currently familiar with the current certificate system, this is especially what comes to trustworthiness of, or how do we trust that we talk with in the web is actually an entity we believe they, or we think they should be. So how can we verify that the identity or DID identity is trustworthy in the decentralized world, like how we're using the X509 certificates in the traditional hierarchical CA world?
So part of the way we look at it is that you would, if you don't know who the issuer is, so part of it will be initially certainly it'll scale up slowly, so you will know who is an issuer and who is not. So that will become tribal knowledge for a while. But the best way it will scale is you will ask the issuer, if you don't know who they are, under what authority are you issuing that credential? And you will find out who authorized them to be able to be an issuer. It will then depend, where it differs from X509 is instead of it all chaining up to a central authority, it'll actually chain up all over the place through these governance frameworks that will determine, perhaps it's a government entity and you are presenting a government ID and you will chain up through until you find a DID you recognize, which is an issuer you trust that says, oh, that's part of the BC government and they're allowed to issue credentials. If it's a university, they would go up through the, associations of colleges and universities, and they have authority to issue diplomas, and that credential is about a diploma. So that basically is the flow that it would happen.
Okay.
I was going to say, we're already, both the Sovereign Foundation and my day job at Evernham, governance authorities, the natural ones and some new ones, are recognized. Oh, wait a minute. We can just create a governance framework, right? This is all open standard. The DID specification is there, the verifiable credentials. You literally just publish a document, and then your governance framework could be as simple as, here's a document with a list of DIDs of the authorized issuers on the ledger, totally verifiable by anyone because they have the keys for those DIDs. You can just walk that tree, but instead of like 200 CAs around the world, we can have tens of thousands, millions, and they're all can be strongly trusted.
All right, and I suppose the trusted issuers could be also outside of the ledger. I mean, on a traditional web server, serving a list of issuers like the BCGov, Oldbook, or others.
You choose who you trust.
Yes.
And but it will all be interoperable. That's the key. I just have to observe. Fantastic questions coming across. I know we're going to run out of time.
Really good stuff. Like could it be a smart contract? The whole.
Can I hit that one really quickly?
Yes.
A verifiable credential is a smart contract. It is a very constrained one. It's saying certain things, but it provides cryptographic certainty that who issued it, who it was issued to, that nothing has been altered on it, and if you have that capability, has it been revoked? That is essentially a smart contract. And so the way we think of it is that is a mechanism, and it absolutely can be automated. So you don't need to have the blockchain sense of smart contract to automate this. The verifiable credential is just that.
And a different way to put that is a smart contract can be thought of a type of agent, right? That can communicate that way, can have a DID, can do all those things, which actually solves a bunch of legal problems with smart contracts.